Hello, everybody still with me? A little more work to do in the headstock bearings. From the last installment, a painstaking process to get the headstock set up on a faceplate fixture. Very carefully aligned a test bar that fits the outboard bearing, both for concentricity and then double checking in two planes to make sure it's truly axially aligned. And it's a matter of setting up the taper attachment, gauge block, sign bar, and indicators. In the last video, I referenced that Schaublin must have bored these bearings out after mounting them in the headstock because the ID and the OD were just so far out. I'd forgotten I had these photos and did this test, but I mounted the original bearing in a 3-jaw chuck and just checked the ID and the OD eccentricity. To prove the point, the OD was a couple of thou out because of the chuck, but the ID was out like 25 thou, which confirms that these bearings must have been bored in situ and there was just no possible way to machine and replace the bearing. It had to be machined in situ. Anyways, it was an interesting learning experience and a heads up for any of you that might encounter this. Setup is as accurate as I could possibly make it, and it was pretty good, but there's still a kind of a final chance to correct any errors, and then I'm going to scrape this bearing. This all in all was the most stressful and least enjoyable part of the project because I just couldn't come up with a methodical, quantified, perfect way to come at it to guarantee results. It was more hold your tongue just so you can creep up on things using many iterations. I confirmed the 3-degree taper was mating fairly well with the shaft. But, of course, the challenge is not getting a fit with tapers. That's relatively easy. The challenge is where the heck are the two tapers relative to one another, and how do you get a fit between mating parts such that there's minimal clearance. And it's fairly extreme in that the shallow 3-degree taper, if you take 1 thou off the diameter of that, you move the mating surface of the 45-degree taper in about 10 thou. So it's challenging. What I did was I got the taper attachment dialed in dead on for the 3-degree taper and then carefully set the compound with the gib fairly tight, set up for the 45-degree taper. Here, for example, you can see on a trial fit I'm making contact with the 45-degree taper but not with the 3-degree taper. So it's skim a tiny bit off the 45-degree taper and check again. I don't have a photograph of it, but one way that I sort of quantified it was I used pin gauge, slipping them in the gap of the 45-degree taper to estimate how much more to take off on the 3-degree taper. It got me close, but it was still a touchy cross your fingers and hope type work. It looks good assembled, but it's still a long way from a perfect bearing fit. To work towards that, it's time to get scraping this bearing. This was another brutally tedious process. These are bearing scrapers. I think they're more sort of commonly used for Babbitt bearings, but I pressed them into service on bronze. The challenge was it's just such a small, awkward space to get into. It's hard to see. And of course, the big challenge of you move the 3-degree taper a tiny bit, you've moved the 45-degree taper a massive amount. With only a few shutters, I managed to get through describing this. However, it was a really tedious job. I don't think I'd do this again. I'd get a big lump of Durabar and make a headstock from scratch using high-end angular contact bearings or something. This just was a very challenging process. I eventually decided to use the non-embedding garnet-based lapping compound to finish things off. I think I was at it close to 2 weeks trying to get perfection on this and finally broke down and used the finest grit I could get. And it did work pretty well. It just took off the high spots that were so exceedingly difficult to get at via scraping and left a nice finish that seemed to be a pretty good bearing. Using some cant clamps, I clamped the headstock to a toolmaker's block and held it in the vise at the right angle so I could run a long ball end mill down to create the oil groove. I decided to machine the bottom of the headstock. It was just too much to scrape, so I was going to rough it out on the mill. I started by putting a ground pin in the spindle and the collet to get the bottom of the mill aligned with the mill's table. I just indicated across this pin and tweak things. The casting is a very irregular, awkward shape to hold, and an idea that worked really well was to fill a baggie with Bondo, set it all up in the vise, and indicate it fairly true, and then let the Bondo set. You can't scrape into a corner, and in corners you need some relief. So I knotted the mill head over, and I used a cutter. It's got a round radius on it. I believe they were used for fluting tap. It came out of the Bertram factory in Hamilton, and they did a lot of work for Pratt & Whitney, so it makes sense that it was used for tooling manufacturing. Anyway, you may have a hard time finding one of those, but you can even use a hacksaw. The important thing is to just get a groove in there so that you have some space for the end of the scraper to work into. That's it for the meat and potatoes of the headstock and the spindle. There's a bunch of kind of minor little housekeeping things I'll just quickly run through. The outboard bearing tightens in on the shaft as the nut squeezes it in on the taper, and that is limited by this spacer that you can see in the photo. I came up with a fit that I was comfortable with, ground it to thickness, filed the profile, and things are pretty good with the outboard bearing. However, because the outboard bearing is further along the shaft now with the changes in diameter, I had to make a little spacer so that the nut would actually engage on the end of the bearing. I started by cleaning up the nut on an external collet, bored a small recess in the bottom of the nut, and turned a spacer ring with a small shoulder to engage in that recess. Thrust is taken up on the spindle by the tapered inboard bearing. However, in the other direction, thrust towards the tailstock is taken up by a spacer that mounts against the pulley and then bears against the left side of the inboard bearing. This, like everything else on this poor little lathe, was in terrible shape, so I cleaned it up on the grinder, strove for a very fine finish, and while I had the grinder going, I also cleaned up the face of the nut just for appearances. That might be a good time to wrap it up. The spindle and the bearings are complete with the exception of regrinding the spindle nose, but I don't want to do that or can't do that until I get the headstock properly aligned to the bed, which should be the topic for the next video. Thanks very much for watching.